So yeah, today I'm going to show you some tricky computations and how they can be interrupted and how they can be computated. So let's start by a really tricky computation. Suppose let's start with a one of the trickiest computation is multiplication. Multiplication is just repeated addition, but you can ask me, if multiplication is just repeated addition, what is 4 repeat, like 4 times 2 liter means you add 2 plus 2 plus 2 plus 2, right? So I explained FOIL method, lot of things. Now this complicated problem, the FOIL method that I explained, it would only work for whole numbers, but in case of like but wait, let me show you. Now like this, right, which is equals to 16. Sorry, what I'm writing, sorry, 8, not 16. Sorry, man. I always make this silly mistake. This phone is so bad. Nice. 8. Look, same as 8. 4 plus 2 plus 2 4, 2 plus 2 4. 4 plus 4 8. Very simple computation. But when you have 0.5 times 2, then how it's equals to 1? Like 5 twos are like if we use a trick, like we multiply with the decimal number, but it still creates a problem. Like what is how? But when you try to get the meaning of it, but how do you add 2.5 times? 2 can't be added 0.5 times. A number or anything can't be added a decimal time, because it doesn't make sense. Like what does 0.5 really mean? Look, every decimal, not every decimal number, like most of the decimal numbers, but like all finite decimal numbers, especially not infinite. Look, I'm talking about not every decimal number, every finite decimal number, like 2.5, that is a finite number of decimal numbers. Every finite decimal number is a representation of a ratio. Every 0 point dot, like any number that is finite, not infinite, like pi, or pi is still a ratio but it's infinite, because any infinite decimal number could represent two things: a ratio or a root. Like yeah, like a root. This is where it gets tricky and problem. Now what does it mean? It means this 0.5, this finite decimal number, is representing a fraction, which means 1 by 2 times 2. That now here comes the more tricky part. Now how do you add 2 1 by 2 times? It's impossible. Like you cannot add any number a fraction times. A fraction times can be added nothing, but it's still repeated addition, but not with the whole fraction. It means it's actually a rewritten form of 1 times 2 by 2. Okay, equals 1. Now 1 times 2 means 2 by 2, which is 1. Now why it is like this? Because underneath this 2 there is a 1. Underneath this 2 there is a 1. So we know the multiplication of division, it gets multiplied with this one and this one with this one. So as a result, that's how they get are actually multiplied. This 2 is not here. This 2 is not being added 1 by 2 times. It doesn't mean it's getting multiplied with 1 by 2. This finite decimal number is literally representing that 2 is getting divided by 2, or 2 is getting split into two parts. It's about scaling. It's not repeated addition in case of division. But when working with normal positive negative whole numbers, that means it's always, look, it's still repeated addition, because but in a different way. Here the dealing is different. Here one whole 1 by 2 doesn't represented the number which this 2 is getting multiplied with. It's representing that 2 is getting divided with 2. Okay, I think you have understood this simple math. It doesn't represent those, like 1 by 2 times 2 doesn't mean that 2 is getting multiplied, and then it means multiplication of two fraction, because every number can be represented as a fraction. 3 can be represented as 3 by 1, so 3 by 1 times 1 by 4. That's how this multiplication works, not just by it doesn't mean that 1 by 4 is added 3 by 1. Oh yeah, it's kind of true, because 3 by 1 is just 3 times 1 by 4. It now means repeated addition. But when you have 1 by 4 times 3, it doesn't no longer repeated addition. It's now a fraction. Now it's now a rewritten form of a fraction. It's literally rewritten form of this. 4. Okay, underneath 3 there is actually 1. So 1 is getting, it's a rewritten form of this, not a repeated addition. But here it's repeated addition. I think you have understood. Now, do you know how ratios actually distribute over sums? Like, we know the distributive property y, because a plus a times b plus c gives you ab plus ac. As b plus c was added a times, so b was added a times, c was added a time. In case of true multiplication, which is just repeated addition. But when you have a by c times a plus, sorry, okay, let's take d plus e. Now what does it mean? How does it distribute? Like how ac getting distributed over de and de, like d plus e can't be added a plus c times, but there it's how it's getting distributed is, it's a literally, the concept is a little bit different here. Here d by e is not getting multiplied or added a by c times. Here it's just a rewritten form of a times d by e, due to the 1 underneath the d by e, which is the full fraction is divided by c. Now what you get, look how it's getting distributed. Now look, the a is actually multiplied with a d by e, so the a d by e is added a times, so you get ad plus ac ae by c. Now if we got ae by c, now we know what, we got ae by c, got ae plus ad. Sorry, I did a little bit. It's ad plus ae divided by c. Now it's same as writing I hate this form. Sometimes you just hate this form. Now it can be rewritten as ad by c plus ae by c. Now it can be rewritten as a by c times d plus a by c times e, because underneath d there is 1, underneath e there is 1. How they are getting multiplied. Look, it distributed over d and over e, ac and a. And look, ac distributed over ad and e. I think you understood that how fractions actually distributed over sum. So that's how it actually. So now if AC is rational or irrational, it doesn't matter. It just gets distributed like this. I think you understand. If you don't, just nothing to say.